first of all today, let's talk about factors for a minute. Factors, this goes with the word product, by the way. So you remember what factors are? What are they? Okay, anything that's going to be multiplied in some way, right, is a factor. So it could just be something like this, where 4 and 3 are both factors. Okay, they're going to be multiplied together, so we call them factors. Sometimes we factor things, so we say what are the factors of 12? So we might think of 1 times 12, or 2 times 6, or 3 times 4. So this is a little bit different, but they are factors, aren't they? Because when you multiply them together, you get 12. So they're the factors of 12. So that's what we're talking about. And the result, product, right? We've been talking about that. Now, there's a new word we're going to talk about today called coefficient. A factor, okay, and a coefficient are the same thing. All right, that's just a different name we're going to use a little bit as we look at algebraic functions and equations. So if I write something like this, 4x. 4 is the coefficient of x, and x is the coefficient of 4. They're factors of one another, aren't they? But what's really important is that you guys understand numerical coefficient and literal. The literal coefficient. Oh, sounds awful, doesn't it? Here we go. Okay, really concentrate. This is going to be tough. Here we go. 4 is called the numerical coefficient, and x is called the... Very good. It's a tough one, huh? So anytime I write a term, we're going to talk about what a term is. So if I write 5a, what is the numerical coefficient? 5. And what's the literal coefficient? Okay. That's pretty much what you need to know. If we write 3mp, can you see the numerical coefficient? Yeah, it's 3, isn't it? And the literal coefficient, there's actually a couple, m and p, but generally we look at them like one thing, and we'll see why that is in a minute. But we could just say mp is the literal coefficient, and that'll work. What about this one? What's the numerical coefficient? 1. Now, we are way too lazy to write the 1, but it's there. When I write a variable like x, I mean 1 times x. But we never write it. It's just easier just to write the x, and you just have to know it's there. All right? Have you seen that before? Who's seen that before? You all get that. Okay. By the way, what about the exponent right there, first power? We don't write that either, do we? But is it there? Yeah. Okay. All right. It's there. So that's what I need you to be able to do. I need you to be able to look at a term like this, and when I say, okay, what's the numerical coefficient? What is it? Simple. What's the literal coefficient? There you go. Okay. That's all you need to do. Now we're going to talk about this word, terms. A term in an algebraic expression, let me read the definition here. It's on page 75. Consists of a single variable or constant, is the indicated product or quotient of variable and or constants, is the indicated product or quotient of expressions that contain variables and or constants. Did you get all that? No. Yeah, me either. I read it and I still didn't get it. So let's just talk about what we really need to know. All right? So as long as it's multiplication or division, it kind of holds itself together in one term. So I'm going to write something here. 4x plus 5mp subtract 3 over x plus 4. Okay. There are 3 terms here. Can you all see the first term? 4x. What's the second term? 5mp. What is the third term? Can we say negative 3 over? So this fraction line right here holds that together as like it's one term. Now here's what's really important. I need you to be able to look at an expression. This isn't an equation, it doesn't equal anything. Look at an expression like this, and when I say, okay, look at the second term. Can you all see the second term? Yeah. What is it? 5y. What is its numerical coefficient? Y. And what is its literal coefficient? Y. Very good. That's what is really important for us to do. Okay? Because we're going to start simplifying expressions like this by adding like terms. All right? So now I guess we have to talk about like terms, don't we? What's that?
Didn't we have this whole lesson yesterday?
Yeah, we talked about it a little bit, okay? So there you go. As long as you guys can look at this and say, okay, the fourth term is 10x and its numerical coefficient is 10 and its literal coefficient is x, which is all pretty simple, isn't it? Okay? All right, now, got a piece of paper? I'd like you to do this problem for me. Okay. How are you doing it? Okay. And then, okay. Anyone in the world that sees that problem, that's what they should do. Simple, do what's inside the parentheses, then multiply, you got it, right? But I just want to point something out. What if I did this? 3 times 5, and 3 times positive 2 is positive 6, and then I added the 2 together. Would it still work? Will it always work?
No.
Let's take a look. Fortune, give me a number.
5.
5. Number? 7. Plus or minus? I can't hear you because of the mask. I'm going to go with minus. Sarah? Number? 12. And parentheses. Okay, let's do it. Let's do it the smart way. 5 subtract 12. Sorry, 7 subtract 12 is negative 5. I said the answer rather than doing it. And this is negative 25. You okay? All right, let's do it the hard way. 5 times 7?
35.
35. 5 times negative 12?
60.
Negative 60. Now I put the, you notice how I put the negative down way before I worried about the 5 times 12? I knew the answer was negative, didn't I? Now if we take 35 and subtract 60, it does work all the time.
How? That's crazy. So why is there order of operation? It's still multiplying.
Yeah, why is there order of operations? See, order of operations, it really matters when, well, let's talk about this. What about addition? Can you do addition in any order you like? What about multiplication?
Yeah.
That's kind of what we're doing here. We're multiplying and adding in a different order, but because it's adding and multiplying, we can get away with it. Now, if it was dividing and subtracting, not so much, right? Now, you might look at this like it's subtraction, but it's not. We're adding a negative 12. As long as we do it this way, we're still using addition. I guess my big question is, why would we? 6 times 3 subtract I don't know, 9. Negative 6. That gives us negative 36. When we can do what's inside the parenthesis, when we can do this, why would we say 18 subtract? Why would we do it that way? Sorry, negative. What's that?
Do a little bit slower if you do it that way.
Wait, say it louder.
Never mind.
Little bit slower if you do it that way.
First way, I didn't even have to like really write it on my paper, and the second way, you have to.
I mean, what do you guys think is easier? Who thinks that's easier? Of course you do. You're all smart. That's easier. So why am I even teaching you this?
To tell us not to do it.
To tell you not to do it? Well, if it works and I'm teaching it to you, there's probably a reason to do it. Sarah, did you say something?
Because people learn differently.
Yes?
Because if the two numbers in parentheses makes a really big number and you don't know what said number times this number is, then you can just
Okay, so he's saying if the two numbers in the parentheses, if that's hard to deal with, and I'll even go a little bit further than that. What if it's like this? Matt, did you want to say?
to double check your work.
Okay, you could double check it. That is a good idea. I like that. And I like your idea too, Wyatt. But what if in the parentheses, not only is it kind of hard to do, but what if we just flat out can't do it?
Then you go 3 something.
So in this case, what's x plus 5? No, that's 5 times x. I knew someone would say that. Thank you. Yes, 5x is 5 times x.
So it'd be 3x.
X plus 5 is x plus 5. That's as good as it gets. Okay? We cannot do what's inside the parenthesis, can we? Okay. However, we can go, well, 3 times x.
3x.
And 3 times positive 5? Positive 15. Okay? So we can do that multiplication. But is it really any better now? I mean, 3x plus 15 is still just 3x plus 15.
Basically the same thing.
It's basically, yeah, it's basically the same thing. It's like, what's the purpose? Why would we want to do it? Yes, Thomas?
Don't you, hold on, so I don't know if this is right or wrong, but don't you divide the 3x to both sides to get rid of the x?
Well, see, this isn't an equation. See, it doesn't equal anything. It's just, it's like this equals something over here, but we don't really care about that part right now. So it's not an equation, it's an expression. So we're only looking at half the equation. We're only looking at one side of the equal sign right now. Okay, so keep that in mind. Mason?
You know how when like some questions it's like 3 times x plus 5, but on the other side it's like 2 times x plus 6. You know how, once you figure them out, you like add the whatever's called the.
So adding the like terms and all that stuff. So I want you guys to look up here at my exploding brain poster. Now we're not solving equations right now. We're just working with half of the equation right now, okay? But I want you to look at the very top, number 1. What does it say? Remove parentheses. When you look from here to here, what have we done? Remove parentheses. Okay? The first step in solving an equation is to remove the parentheses. If you can't do that, you cannot solve the equation. Okay? So what we're learning about today is we're learning just how to get rid of the parentheses so we can move forward. Now we're not solving equations yet. All right? We're not solving an equation yet. Your job is not to figure out what the value of x is, because this isn't an equation. All your job is to get rid of the parentheses by using this property. Anybody remember what this property is called from last year? Yeah. Now, by the way, it's a property of mathematics, which means it works all the time. If it doesn't work all the time, it's not a property. So we have something like 4 times a minus 2, a subtract 2. Your job is to get rid of the parenthesis by using the distributive property. All we have to do is go 4 times a. Oh, wait a minute. Let me make something clear. What's the numerical coefficient of a? 1. So you're going 4 times 1a. 4a. And then you're going 4 times negative 2. That's it. So 4 times a subtract 2 is the same thing as 4a subtract a. They mean the same thing. Only this one, no parentheses. That's a big deal. Big deal. I need to find my poster. I had a poster that said the distributive property, and then it had this big set of red lipstick marks on it, and it said kiss your parentheses goodbye. That's the whole point of the distributive property. Okay, get rid of the parentheses. It's pretty simple. We have I don't know. Let me try a different one here. How about this? X times a plus b plus c. What has to be multiplied by x? Everything, exactly. Everything in the parentheses. What is x times a? XA. What's x times b? XB. What is x times c? XC. Now, if you would like to put ax plus bx plus cx, that's also correct. It doesn't matter what order you list the variables in, you're going to get the same thing. Because when we multiply, isn't that commutative? Doesn't matter what order you multiply in. Now, listen carefully. Listen. I'm always going to write them, almost always, in alphabetical order. There's a good reason for that. It's going to make our life a little simpler down the road. However, if you don't write them in alphabetical order, you're not wrong. I wouldn't mark it wrong on a test or anything like that. It's the same thing. But I'm just going to tell you right now, it's a good idea to put them in alphabetical order, or at least all in the same type of order to help us out down the road. How about this one? What if I put the 3, what if I multiply it over here? Does that make any difference if the 3 is written here or written here? No, it doesn't. And you're still going to do it as if it were written in front. You're still going to go 3 times x. Now, is that a positive x or a negative x? That's a positive x. So that's 3x. You're still going to go 3 times what?
Negative 9y.
Okay, so that is negative 9y. And we're still going to go 3 times 1a, which would be 3a.
We're 3a, right?
So these mean the same thing. And we really are simplifying it. Getting rid of the parentheses is simplifying it. It's making it simpler. That's your job. Okay, everybody do this one yourselves on your paper. Just like when you do it in the book, don't write down the original problem. Don't write down this problem that I wrote on your paper. You can just write the answer. You can use the distributive property. Negative 3 times 2 times x. And negative 3 times negative 4. Positive 12. Is that what you're thinking to yourself? Negative 3 times these? Watch that sign. Make sure that not only do you distribute the 3, but you distribute the negative as well. You do that one? Don't write down the original problem. Just use the distributive property Your instructions are expand by using the distributive property. So take the 2m, multiply it here, multiply it there. Is it what?
There's no like terms.
We're multiplying, so we don't care about like terms. So we only care about like terms when we're adding. When we're multiplying, we can multiply any term times any other term. Okay, so 2 times what? What's the numerical coefficient right here? 1. Okay, so you guys know what 2 times 1 is. And then what's m times x times y? Okay, now I want to point out something to you guys. You just told me that m times x times y is m times x times y. You didn't actually do it, did you? It's almost like you're being a little bit of a smart aleck on that one. You're just saying that's what it is what it is. Okay, so now what's 2 times negative 3? Okay, and then we also have m times p. Negative 6 times whatever number m is times whatever number p is. That helpful? Here, try this one. Okay, what's x times y times a? You're right, you're right. And then, is there a 1 right here? Is there a 1 right here? And what's 1 times 1? Now, did we write any of those? Can you if you want to? You betcha. Okay, now, we did that one, now let's multiply over here. X times y times b. 1xy times 1b is 1bxy. And then xy times negative 2, so 1 times negative 2 times x times y times c. And I am going to put things in alphabetical order. I'm going to put the variables in alphabetical order. You'll see why. That's the distributive property. What's the point of the distributive property? What's the big deal about it? Get rid of parentheses. That's a big deal because you guys are going to be solving equations soon. And if I gave you an equation, even if it were pretty simple, you could not solve that equation. You could not find the number that makes this equation true without doing what? Distributive property. That would be the very first thing you would have to do. Do you remember this? Who did this last year? Did you solve equations, right? Okay. First thing every single time is you have to look at both sides of the equal sign, and if there are parentheses, somehow, some way, you got to get rid of them. And usually it's the distributive property. Okay? So this is a big deal. Okay, we are working on set 17. Go.